Good day, grade 10 students. Today what we're learning about is classifying matter. We're going to talk about what matter is, we're going to go through how we classify it, and we're going to talk about what each classification is. Here we go, classifying matter. Okay, so what is matter? Well, if we take a look at what matter is actually everything around us. It's almost everything. If you want to think of matter as everything except a vacuum. And a vacuum, not an actual vacuum at home, but a vacuum meaning something where you have a box, you remove all the air from it, and there's essentially nothing in there. That's what a vacuum is. So what is matter? Matter is anything that has mass and takes up space. And it's everything around us. Cars, trees, anything that has mass and takes up space. So again, it's just about everything. And what it's made of is, we're going to find out, is it's made up of atoms. And we can find, so it's made up of atoms, but we can find it in three states: solids, liquids, and gases. Now this is technically a little bit of a lie. There's actually one more thing called the plasma, but we're not going to talk about it here. So, solids, liquids, and gases. How do you turn one into the other? Well, you might know this. If you add heat, what happens is you're adding energy, and it's causing these molecules to move faster and faster, or molecules and particles to move faster and faster. And as they move faster and faster, they move farther and farther apart. So when you heat something, you're adding energy, and that's causing those atoms and molecules to move faster and faster, farther apart. And eventually, they go from a solid to a liquid to a gas. Now we can do the reverse as well. We can take any object, anything at all, any pure substance, like a piece of metal, for example, and if we had a metal gas, that may sound strange. A metal gas would be very, very hot. If you cooled it down, eventually it would turn into a liquid metal, and eventually it would turn into a solid metal. A better example is like steam. That's hot. If you took steam and you cooled it down, it would eventually turn into water, liquid water, and eventually would turn into a solid, which is ice. So here's a better way to look at it. Solids have a fixed structure. They have a fixed shape. Oops, let's back up there. So solids have a fixed shape, like ice. You know, ice, an ice cube doesn't change its shape until it melts. But when it melts, you know that, ice will take the shape of a container, or sorry, water will take the shape of a container. Ice will not. So if you put ice in a glass, it's going to still have that cube shape. But as it melts, turns into a liquid, it loses energy, and it doesn't have a fixed shape anymore. It kind of changes its shape to fit the container. And as we add even more heat, guess what? It won't even stay in your container at all. If you heat up the water in your glass, for example, what will happen is that water will turn into a gas and will leave that glass, and it will fill up the whole room. It doesn't have a fixed shape or fixed volume. So how do we change, again, from one state to another? We add heat. If we add heat to a solid, it goes to solids go to a liquid, and eventually to a gas. And if we remove heat, we go back in the opposite direction. Well, we actually have names for all these changes, and you've heard them before. When you go from a liquid to a solid, like water to ice, you are freezing. If you go in the opposite direction, you're melting. These are obvious. If you take a liquid and you heat it up, it'll turn into a gas, like water into a vapor. That's called evaporation. If you go in the opposite direction, gas to a liquid, it's called condensation, rain. There's one that you might not know. Do you know its name? Well, it's sublimation. Sublimation actually goes from one to the other. And the only thing that I can think of that does this, that comes to mind, is something called dry ice. And dry ice is a solid. It looks like ice. It's very, very cold, but it doesn't even turn into a liquid. It just jumps immediately to a gas, and that's the smoke that it makes. That's why it's called dry ice, because there's no water in it. It's dry. Okay, so I hope you've done this before. You can write this down, but I want you to classify matter into what we call a concept map. And I want you to stop in a second, and you can do this on your own. I prefer if you did it with a partner. But we have a couple different things. All matter, these are all just categories of matter, including matter itself. Here's matter. So we have heterogeneous mixtures, pure substances, matter, element, compound, solution, mixture. So what I'd like you to do is arrange that from the most general, which is going to be matter. It's going to be at the top, and we're going to divide that into smaller groups. And this is what I mean. So we're going to take matter, we're going to put it at the top here, matter. And then what we're going to do is we're going to turn it into two general groups, okay? And those two general groups will be written here and here. Oops, that looks a little messy. And we're going to divide it into two other subgroups, okay? So I'm going to give you a moment to see if you can do it. Oh, that was too quick, eh? So the first classification is something known as pure substances, and other classification is something known as mixtures. So everything around us can be divided as pure or mixtures. Pure things, for example, water, that's pure, okay? As long as there's nothing in it, pure water would be a pure substance. Mixtures would be like your chocolate chip cookie, okay? Now we can divide these into each pure substances and mixtures into two smaller categories. Well, what are those? Pure substances can be divided up into elements and compounds. Elements are all those strange words that are on the PT, the periodic table. That's P/T, periodic table. Everything that's on there. Compounds are actually combinations of elements. For example, like water. Water is made up of the element hydrogen, that's on the periodic table, and oxygen. Okay, it's a combination. 2 hydrogens for every 1 oxygen. That's H2O. That's a compound. Now, so water is a type of pure substance. It's the type that it is it's a compound. Elements like gold, Au, that is just one element that is on the periodic table. What about mixtures? How can they be divided? Okay, well, they can be divided into two groups. One is known as homogeneous mixtures, like homogeneous milk, which basically means like it looks all the same. Like the first sip of homogeneous milk, maybe you've never had it before, it tastes the exact same as the last sip. Well, you could put milk in, any type of milk, into that category. Well, previously, when you would get milk from a cow, I don't know if you knew this because there's probably not any farmers here, but previously when you get when you get milk directly from a cow, it's a heterogeneous mixture. That means that there's actually there's some curds and things at the top of that milk, and then there's the milk below it. So you can see the curds and you can see the milk. It's two separate things that are mixed sort of together, and you can see the curds and you can see that milk part that we'd normally drink, and that's why it's a heterogeneous mixture. You can see those two phases. So let's define each one of these specifically, and you should write these down into your notes. Okay, so pure substances. You can define all pure substances. That's the major classification as either they're all made of the same type of particles. Particles are really tiny little things. Particles can either be like atoms or they can be molecules. That's all you have to know, okay? And if you have a pure substance that is a compound, made up of elements, it cannot be broken down into simpler substances. And these are the things that are found on the periodic table. For example, O, oxygen, hydrogen, helium, anything that's on there cannot be broken down any simpler. So we'll talk about what those are. But these guys, elements, are basically atoms. And this is important that we know that. Compounds are two elements that are chemically bonded together. So for example, carbon dioxide, carbon on the periodic table, oxygen or oxide on the periodic table, CO2. Okay, that's carbon dioxide. That's two elements bonded together. Water, H2O, 2 capital letters. Sodium chloride, NaCl, 2 capital letters. That salt is NaCl. That is a compound because it is bonded together to make salts. Sodium is not salt on its own. Chloride is not salt on its own. NaCl, sodium chloride, is salt together. So what you need to know for this is compounds. The simplest compound that we can have is something known as a molecule, which is basically just like an element. It's just one of them. It's a bunch of atoms bonded together to form a molecule. So on the other side we have mixtures, and mixtures can either be homogeneous mixtures, also known as solutions, okay, or heterogeneous mixtures. And homogeneous mixtures are things that are mixed very, very well together, like homogeneous milk, Okay, it's mixed well together. You can't see different parts to it. If you leave your milk in a glass, their stuff is not going to settle out of that. You'd be really grossed out if you left your milk for a second, you came out back and there was a layer of fat on the top. That wouldn't be pleasant. So it's only one phase. That means that word phase, guys, what that means is like you can only see one thing. It's hard, you can't detect more than one thing. So for example, another thing would be like salt water. You can't see the salt, you can't see the water, you just see it all together. That's one phase. So that's a homogeneous mixture. So parts cannot be separated by filtration. So you can't just like filter out the salt out of the water. It doesn't work that way. Some other examples for you. Air is a homogeneous mixture. Air is not, well, it's not a pure substance. It's actually oxygen molecules in there, nitrogen molecules, a bunch of different things that are floating around in the air that are well mixed together, and you can't see the difference, so therefore it's a homogeneous mixture. Heterogeneous mixtures are, you can clearly see they don't mix well. You can see the different phases. An example are like pizza, salt and pepper, oil and water. You can see the difference. Chocolate chip cookies is a good example. You can't see the difference between these things. So that's it for now. That's the end of our video. I hope you enjoyed it. Please answer the following questions. I'll put some questions up for you to answer after this. Thank you very much.